Okay, onwards with this mega torch build. Let's have a look now at the CPU cooler that I'm going to use to mount the LED onto. The LED will be mounted onto this surface here, which was in direct contact with the CPU in the computer. This whole fan and heatsink assembly will be mounted inside a tube. Now, this is a piece of normal sized 90mm tubing. It doesn't quite fit round, which is a bit annoying, but then I discovered that if I get a joining piece, so this is a union piece for 90mm pipe, so that actually slides inside. This then goes in there just like a hand in a glove. It's an absolutely fantastic fit. Now we do have these legs here which are going to need bending up, and there's a couple of sort of clips here which need trimming to let it go further in, but I think that's going to be an ideal mount to get that inside the tube there. Now in terms of mounting the LED, as you might have seen in an earlier video, so this is the large 100-watt LED. That's going to be placed directly on the heatsink. I'm then going to be using this reflector and lens arrangement, and to hold everything in place we'll be using this metal clip. These three parts came as a kit for a few dollars from eBay, and so that will mount to these legs here. And yeah, we should be able to take the build on to the next phase and make sure that this cooler is actually going to be man enough for the job to keep that 100-watt LED cool when it's actually 100 watts output. Anyway, so I'm going to cheat a little bit because I actually had two of those coolers and so I've done all the work that I've just described there. You should be able to see that the LED is now sandwiched behind here. I've got 4 posts here, which are these hexagon mounted posts, M3 nuts in the top, threaded M3 down into this metal base. I did put some Aryl dye 2-part epoxy just on that thread because it's only going through quite a thin web there, and whilst the thread was holding okay, I just thought it would be a good idea just to lock those down permanently. The wires come back through here, come back onto this other part of the loom for the fan, and I've also just temporarily fitted a 10K thermistor. Now the thermistor is on the aluminium plate. It's not in the center where the actual die is, so I'm not going to be measuring the actual temperature of the die, but I'm hoping it's going to be within, say, 5 degrees centigrade of what it is. I want to make sure, as I said, that this cooler can keep this die, this LED, cool at its full rated output. Okay, the other point is that these arms bent up quite easily, just using some sorts of grips and what have you. So what we have now, if I can demonstrate quickly, that this whole unit, apart from the fact that I put a tie wrap on there, so that now slips so tightly in that I'm hardly going to have to mount it up, but if I just push that a little bit further in, you'll see, gosh, that is really very tight now. So I'm hardly going to have to hold it in position, but yes, there'll be 4 nuts and bolts just on these arms, and yeah, that should hold everything in position quite nicely. But let's do some testing first, make sure everything's from a thermal point of view is okay. So beware, Heath Robinson has been around and set up all this wiring. It is a bit of a mess, but it's just a lash up to try and do some calculations and measurements. What I've got is three 12-volt batteries here going into this Minghe power supply, and this is going to emulate the battery going into the power supply. Now, in my earlier videos I actually had this power supply, and this was working fine until I managed to break it. Managed to connect up the positive and negative the wrong way around. So there we have it. That's no longer usable, so I'm using this boost regulator. Should be fine. It's good for 150 watts, and we've got a 100 watt LED in here. So moving on the output side, I've got this little voltmeter here, and I've got this Bryman as an amp meter in the circuit. This will show me the power going into this DC to DC converter. These two will show the power going out to the LED. Finally, this meter is wired across the 10K thermistor, and it's currently showing 9.27 kilo ohms. Okay, so looking at this printout very quickly, 9.8K, somewhere just below 10. Yeah, so it's probably about 26-27 degrees here. Finally, it has cooled down in Sydney. It's been so hot the last few days. I haven't been able to do much in the garage at all. But yeah, so we'll be able to use this to determine how high the temperature goes. Now, as I said, the thermistor is not right underneath the die. It's about just off to one side, so I really don't want it to go over 60 degrees centigrade, because that's going to seriously degrade the lifetime of the LED. I'd much prefer it to be below 55 if possible. So anyway, let's move on. I've wound the potentiometer right out on the control here, so we shouldn't get too much. We've got 25 point. What I'll do actually is I'll just come in a little bit closer on these meters now. You don't need to see around. So yeah, you can see the lamp has just come on. 25.2 volts coming into the controller, 25.1 coming out, so it's not doing anything really. And yeah, the bugger all ampage, but yeah, it's enough to light the lamp. Let's see if we can't tweak this up a little bit. So here we go, you can see the lamp getting much brighter now. I might want to just shield that slightly so it doesn't completely wipe the camera out. Does that make it better or worse? I think it makes it worse. Never mind, let's see how we go. So, primarily using this to start off with. So putting in 12, 13, 17, 20, which will, inductor here is singing a little bit. You probably can't hear it on the camera, I can hear it working away. So we're up to 30 watts. Oh, it's quietened down now. 50 watts, 60, 70, 80, 90. Let's just leave it at 90. It's just going over. Oops, yeah, 97 watts. Okay, so seems to be settling down a little bit there. So we can see this reading here is coming down quite rapidly, down to 6.5K. If I bring this in again, 6.5K is smack on 35 degrees. Let's just speed the video up at this point, but let it come to a settling temperature. We can see that the wattage has settled out at just over 100 watts. Let me just back that off. I don't really want to overdrive it. Oops. Yep. So apologies for the exposure there. The light is so damn bright. It's going to be great when it's finished, but it's terrible trying to do testing. Focused in just a little bit closer on these, you can still probably see it's still running there. We've settled out at 4.39k. Let's just take a quick look at this. So we're in this sort of region, 4.3, yeah, around about 40 degrees, sorry, 45 degrees centigrade, probably just a tad under, but as I say, that's on the edge of the die. Once you're right underneath that LED, it's going to be a little bit warmer, hopefully not more than 50 though. Just looking back at these two numbers though, it may be quite interesting just to do a quick calculation. What have we got? 3.145, just bring this in shot, and multiplied by the voltage, which seems a bit low to me, does that? So we're inputting 96 watts into the LED, and we're using 99. Yeah, that looks incredibly efficient. I can't believe that that's like 95% efficient. Those are getting fairly warm, nearly too warm to touch, but yeah, maybe 40-45. Not too worried about that because I will put that in the airflow as well. Let's just check this voltage here. I don't think I need to keep that on. Let's just pop that onto voltage, and maybe if I just very quickly, 30.4. yes, it's a little bit low, but that's pretty accurate actually. So yeah, it looks like this is actually quite an efficient device, so that's good. Anyway, I think that's enough. We've proved that this cooler is going to be okay. This power supply is going to be fine. I just need to work out a way of getting this adjustment. I'll just zoom out a bit now and turn the lamp down. So if I can work out a way of getting this 10k potentiometer to the outside casing of the torch. Anyway, that's the next episode. See you later. Bye.